Hello and welcome back. Last time we got up to external storage devices, and just a quick recap. We said these are plug and play media which are used to transfer files between computers, and we looked at the various examples like optical disks, flash disks, external disks, disk drives, memory cards, and magnetic disks. Now, today we want to look at a very important feature when using computers and when designing software or any other computer-based or mobile-based application or device. We want to look at accessibility. Now, accessibility features are designed to help people with disabilities to use technological devices more easily. For example, a text-to-speech feature may read out text loud for people with limited vision, while a speech recognition feature allows users with limited mobility to control the computer with their voice. And of course, this is like the way you can use Siri or something like the way you can use your mobile device and issue voice commands, and it's able to execute the commands that you issue to it. Now, some of the common accessibility features are given in the next slide. So the features for blind or low vision computer users. Features such as text-to-speech allow users to hear what's on the screen instead of reading it. This one basically helps people with limited vision or visual impairments. Other features like high contrast themes and enlarged cursors, that is especially in computers, make it easier for users with limited vision to see the screen. We have features for deaf or low hearing computer users. Closed captioning helps to convey audio information to deaf users in visual form. I'm quite sure you have seen this on YouTube where we have that closed captioning. If you're watching a video, maybe you don't want you in a, like let's say in a library, you want to watch a video and you don't want to disturb people. You can actually mute the video and switch on closed captioning, and you're able to follow along the video even without the sound. I know, of course, you can always use headphones. Now, the other feature is mono audio systems, which transmit right and left audio signals through both earbuds or headphones, so that users with limited hearing in one ear will not miss part of what they're listening to. I know we really love music that has that stereo feel, but it's always good to consider those people who have maybe they can only hear through their right ear only, or maybe their left ear only. So that is why we change the audio to mono, so that they don't miss any part of it. We also have features for limited mobility computer users. So keyboard shortcuts are convenient for many people, but they're especially useful to those with difficulty physically manipulating a mouse. For users who have difficulty pressing several keys at once, sticky keys allows them to press keys at a time to activate a shortcut. These are actually very useful, that is especially the keyboard shortcuts. They save you a ton of time, especially if you want to work very. So this makes it very easy for you to use the computer. We have the screen magnifiers. Screen magnifiers can be placed over your computer's monitor to ensure content on the screen is always appears magnified. And today, most people use the magnifier or zoom feature on the operating system to view content, but external magnifiers are still available as well. For example, in Windows, when you tap on the window key and you are able to activate the magnifier. You can just give me one moment. Okay. Now you can see this is now what you're calling the magnifier. Okay. And you can see now the area where I'm hovering my mouse, the screen, or you're able to see the text in what? The text has been magnified. Okay. So that is how the magnifier works. Now we have alternative keyboards. So for people who have difficulty using standard keyboards, there are a range of alternative options. You remember in class I discussed about like the QWERTY keyboard. The QWERTY keyboard is the most commonly used. Most likely the computer that you are viewing this on could be using a QWERTY keyboard. Okay. I also told you we have like the Dovak keyboard, and this comes from the arrangement of the first few keys. Also, we have there are quite a number of options. For example, users can purchase keyboards with larger keys that are easier to see or press. They can also buy keyboards with alternative key arrangements, including arrangements for people who can only type with one hand. Let's say you are involved in an accident and you lost an arm or something like that, maybe a finger, all those taken care of. We have the switch adapted peripherals. Now, switch devices allow people with limited mobility to control technology with very small motions, such as maybe a puff or a breath or a head movement. Switch adapted mice and keyboards make it possible for disabled users to interact with computers, even if they are unable to operate peripherals with their hands. After this, we have finished the part on hardware, and now we want to move on to software. Now, software. Computer software, or simply software, is a collection of data or computer instructions, and they tell the computer how to work. This is in contrast to the physical hardware. We remember we defined hardware as the physical or tangible parts of the computer. And it is from these parts that we build the computer, and they actually perform the actual work. Now, software, that is the instructions that tell the computer, we are saying software are the instructions which tell the computer what to do. Software comprises of the entire set of programs, procedures, and routines associated with the operation of a computer system. And the term was coined to differentiate these instructions from the hardware, that is the physical components of the computer system. A set of instructions which direct the computer's hardware to perform the specific task is called a program or software program. Now, software is divided into two broad categories. That is, we have the system software and we have the application software. Let's start by looking at system software. Now, system software aids the user and the hardware to function and interact with each other. Basically, it is a software to manage the computer hardware behavior so as to provide basic functionalities that are required by the user. In simple words, we can say that the system software is an intermediary or a middle layer between the user and the hardware. You can think of this like when you want to use a computer, we have the physical devices, your mouse, your keyboard, microphone, monitor, and to get all these devices to work together so that like when you're clicking the mouse, what interprets that is a click, that is a double click, that is a triple click, that is letter A which has been pressed on the keyboard. What exactly does all that? That is the work of the system software. When you first turn on the computer, which we call booting, it is the system software that gets initialized and loaded into the memory of the system. We discussed that in class, if you remember. The system software runs in the background and is not used by the end users. We don't get to interact with it directly. It is the reason why system software is also known as the low-level software. Examples of system software include the operating system, device drivers, firmware, programming language translators, and utility program or utility software. Let's start by looking at operating systems. Now, the operating system is the most prominent example of system software, and it's a collection of software that handles resources and provides general services for other applications that run over them. Although each operating system is different, most of them provide graphical user interfaces. We abbreviate that as GUI, through which the user can manage the files and folders and perform other tasks. Every device, be it a desktop, laptop, your smartphone, requires an operating system to provide basic functionality to it. Now, the operating system essentially determines how the user interacts with the system. Therefore, many users prefer to use one specific operating system for their device. For example, like when I'm working on the computer, I prefer maybe working with a keyboard and mouse. It makes life a little bit easy. Okay, you can use keyboard shortcuts and such. When working maybe with a mobile device, let's say your tablet or something like your handheld phone, it's easier to work with a touch interface. Okay, I know nowadays with technology we're integrating all these technologies, and we have brought the touch interface to the computers and laptops. Each of these, there's a way we are used to working with each of these devices, and that's why we are saying each one of us has our own preferred way of working. Now we have various types of operating systems, such as real-time operating systems, embedded operating systems, distributed operating systems, multi-user and single-user operating system, internet-based operating systems, mobile operating systems, and many more. You can actually go online and look at more details into each of these. Now, it is important to consider the hardware specifications before choosing an operating system, and some examples of operating systems are given below. Now, the question maybe you might be asking is, why do I need to look at the hardware specifications before I choose an operating system? Now, older computers, of course, will have lower specification hardware. You remember we discussed about the RAM, we discussed about the processor. If you have less RAM and you have less processing power, then you don't need a very strong, hot, or heavy operating system. For example, the computers that we use, or maybe even our phones, they cannot handle something like a server operating system, because it requires some top-notch specifications, as in it's going to handle multiple users at the same time and even manage a network of various computer and other services. Okay, so some examples of operating systems are given below. We have Android, which is used on mobile devices, CentOS used on computers, iOS is used on mobile devices, Linux is used on computers, Mac OS also on computers and laptops, Microsoft Windows, we use it on computers and laptops. The same for Ubuntu and Unix. Now, for the Windows, Linux, and Unix, we have the server versions, which will now be used on server computers. Now, after looking at operating system, we move on to the next category of system software, that is the device drivers. Now, a device driver is a specialized software program that allows the operating system and other software applications to communicate with a hardware device. Device drivers act as translators between the hardware components of the computer system and the software which uses these components. Hardware devices that need a driver to connect to a system include display, okay, sound cards, printers, mice, and hard disks. For example, if you're using a laptop and you connect a mouse, you will notice there's a pop-up that appears telling you configuring whatever kind of mouse that you've done, what you've connected to the computer. That means that the operating system is loading the driver, okay, that specialized software that will allow communication now between your computer and that device that you have plugged in. Key functions of device drivers. We are saying hardware abstraction. Device drivers abstract the details of how hardware works, allowing the software to interact with the hardware without needing to know the specifics. And this abstraction we are simply saying is that we are isolating how exactly does this work. For example, let's say you type in letter A on your keyboard, you really don't know what exactly happens within there, if it is your mobile phone or within your computer. But you know, once I tap on letter A, I expect to see an A on the monitor, okay, or my phone's screen. The next one is communication. They facilitate communication between the operating system and the hardware devices, ensuring that commands and data are properly transmitted. I was using the example of your mouse. When you do a click, okay, 2 quick clicks, that is the double click, or 2 clicks, how is the computer able to distinguish between the 2 clicks and a double click? Okay, so there's that communication, and of course that is courtesy of the device drivers. Next, we have control. Device drivers manage the operations of the hardware device, including the configuration, data transfer, and error handling. And this could be like, let's say you are connecting your computer to the network, or like, let's say you are connecting your phone to Wi-Fi. Now, there is some configuration that takes place. For example, when you're connecting your laptop or mobile phone to the network, it's actually going to ask you for some hot password, especially Wi-Fi. Okay. Or maybe nowadays you can use the QR code to connect to the Wi-Fi. Now, that configuration, it's actually going to allow your computer or your mobile device to be assigned some address that will allow it to communicate on the network. And hence, you can then, like, let's say, send somebody pictures using WhatsApp and so many other things. Resource management. They help in managing system resources such as memory and processor time, ensuring that the hardware operates efficiently. Now, these are software, and once you have the proper drivers, okay, they will enable your computer, because we said for any device to communicate with your computer, it must be connected to the motherboard. And of course, we need to know, like, for example, let's say I want to print. If, like, let's say your printer is taking too much memory, okay, the network card or something like that, how do we handle such? Okay, so we need these drivers to ensure that all these devices are being efficiently managed, okay, such that they each get the required memory and processor time. Now, further, there are two types of device drivers. So this is a bit technical. You can go and look this up on Google. We have the kernel device drivers and user device drivers. Okay? Now, examples of device drivers are, we have the BIOS drivers, we have the display drivers, motherboard drivers, printer drivers, sound card drivers, and USB drivers. Now, having looked at that, that is the device drivers, we now move on to the next category of system software, that is firmware. Okay, firmware is permanent software that is embedded into read-only memory. We call read-only memory ROM. And the reason why it's called firmware, this comes from the firm that makes the device that you're using. If it is a phone, it will come from, if your phone is, I don't know, an Android phone, it will come from the various manufacturers of various Android phones. If it is a computer or laptop, it will come from the various companies that make or manufacture what? Laptops or desktops, okay? That's where the name firm comes from. So it's called firmware. It provides essential information regarding how the device interacts with other hardware, and firmware can be considered as semi-permanent, as it remains permanent until or unless it's updated using the firmware updater. Some examples of firmware are, we have the BIOS, that is the basic input-output system. We have the smartphone firmware. We have the EUFI, that is the Unified Extensible Firmware Interface. We have the printer firmware, router firmware, and so on. So there are quite a number of different firmware depending on the kind of device that you are about. Now, having looked at firmware, we move on to the next category of system software, that is the programming language translators. Now, programming language translators are mediator programs on which software programs rely on to translate high-level language code to simpler machine-level code. Besides simplifying the code, the translators also do the following. One, they assign data storage, okay, where the various variables, okay, not to get too technical, but I'll give you a small illustration, okay. Where is the data of the application going to be stored? That is what I was referring to, variables. They enlist the source code as well as the program details, okay. They offer diagnostic reports, especially like when you're debugging a program, okay. Debugging simply means removing errors from a program. They rectify system errors during runtime. Okay, system errors could be, so some example of system errors could be like, let's say your program is trying to access a file that does not exist. Okay, so how do you handle something like that? Okay, another example could be data type mismatch. For example, somebody is supposed to enter their age, but they are giving you their address. So that is what you're calling data type mismatch. So how do you handle something like that? Now, examples of programming language translators are given below. We have the compiler. So the compiler is the program that translates the entire source code of a high-level programming language into executable machine code by reading the complete source program as a whole, and then generates an equivalent program in machine language. So like we have the C# compiler or the Java compiler. Let me show you a quick demonstration. Okay, you can see here we have a very simple program, and you can see the comments. The description of the program is that this is a C# program that accepts two numbers from the user, adds them, and displays their sum. So we have the class addNums and the main method which begins program execution. Now, what you're seeing here in green, these are called comments. Comments are descriptive text that explain what the program does. Then we have the main method. The main method simply is the entry point to your application, or the launching point of your application. Okay. Now we can see here in line number 15, here we are prompting or asking the user to enter two numbers. So we tell the user, don't worry about the internal mechanics, you guys are not learning programming. But here you can see we're asking the user to enter two numbers, and we'll tell you the sum. So we have these are just called variables. So this is the first number. This is where the first number is going to be stored. You remember we've talked about storage, that is assigning data storage. Okay. If we just backtrack a little bit, so you can see this is what you're talking about. Then we have these two numbers. Okay, we are going to read this in, and then now we display the result. So this is going to be used for output. So we're going to display the sum of, that is num1 plus num2 is, so we add the two numbers. Now to do this, the program is going to be executed. I would like you to look down here. Let me just do this so that now we can run the program and see exactly what it does. So I'll click here. Okay. So I'll click on this button to launch the application. Okay. And you notice there's something that it's doing. Okay. So we wait for it. Now it has compiled the program, and you can see now we have the output. I don't know how well you can see this. Okay. So we can see now the program is actually displaying what it is that we wrote down here. And we are going to use some very simple values. I'll enter 5 as the first value, then 3 as the next value. And now you can see that it's giving us the sum of the two numbers is, that is the sum of 5 plus 3 is 8. So that is how simply a compiler works. We can continue. We move on to the interpreter. The interpreter is a program that takes high-level code, that is code written in languages like Python or JavaScript, line by line, translates it into machine code. That is, machine code is the language that your computer understands at runtime. Now, what exactly is this we are calling runtime? Runtime is as in, runtime is when your computer is executing that particular script, okay? Then we execute that immediately. Okay. So the difference between the two is, so compiler takes the entire source code. Okay. Interpreter is line by line. Okay. The other hand, we have the assembler. Now, assembler is a program which translates the program written in assembly language. Assembly language is a low-level language, and this will now be converted into machine code. Machine code is simply ones and zeros. Okay. The assembly language instructions, that is mnemonics like add, mul is short for multiply. Okay. Sub is short for subtract. Okay. Add, I think it's pretty obvious. They are converted into binary. Binary code, binary simply means ones and zeros. Okay. That is the computer's native language. The assemblers bridge the gap between the humans and the machine, and this facilitates or allows communication. An example of an assembler is NAS-SM, that is netwide assembler. Okay, and this is used for Intel x86, that is the 32-bit architecture. Most of our machines nowadays use the 64-bit what architecture. Okay, if you're interested, you can go look at 32-bit and 64-bit architecture. Let's move on. After looking at programming language translators, we move on to the other category of system software, that is the utility applications. Utility software is designed to aid in analyzing, optimizing, configuring, and maintaining a computer system. It supports the computer infrastructure, and this software focuses on how the operating system functions, and then accordingly, it decides its trajectory to smoothen the functioning of the system. Software like antiviruses, disk cleanup and management tools, compression tools, defragmenters, and so on are all utility tools. And some examples of these are given below. So we have Avast antivirus, Directory Opus, McAfee antivirus, Razor Cortex, Windows File Explorer, and so on. So you can see the rest of the examples given down here. So that is it for the system software. We want to move on to the next category of software, that is the application software. Application software, is also known as end-user programs or productivity programs, are software which help the user in completing tasks such as conducting online research, jotting down notes, setting alarms, designing graphics, keeping an account log, doing calculations, playing games, listening to music, watching movies, all these activities, even like the way I'm using giving this presentation. Okay, I'm using an application software. So application software is broken down into various categories, and we'll start with the first one, that is word processors. Word processors are applications used for documentation, and along with that, so we're saying it helps in storing, formatting, and printing of these documents. And some examples of word processing applications are Word. I believe everybody knows Microsoft Word. We have Corel Word Perfect, we have Google Docs, AbiWord, and of course we have Apple iWork Pages. We move on to the next category of application software, that is database software. This software is used to create and manage a database. Okay, a database is simply a collection of related data. It's also known as a database management system, or in short, DBMS. Now, the DBMS helps with the organization of data, and some examples of database management systems are, we have Postgres SQL, SQL Server, Microsoft Access, we have MySQL and MariaDB, and of course we have the scaled down version, which is SQL Lite. We have multimedia software. Multimedia software is the software that enables you to play, create, or record images, audio, or video files. And we use them for video editing, like the way you're watching this video. I used some form of video recording and editing software. Okay. We have animation. If you look at, as you enter our premises, on that monitor, there is always some animations which are playing by our previous animation students. So how did they create that? So those are the softwares that they use. We have graphic software, we have image editing, And some of the examples of multimedia software are given below. We have Adobe Photoshop, we have Inkscape, MediaMonkey, Picasa, VLC Media Player, Windows Media Player, and Windows Movie Maker. This is just a tip of the iceberg. There are so many other multimedia software. We also have education and reference software. These types of software are specifically designed to facilitate learning on a particular subject. There are various kinds of, sorry, we're saying that these types of software are specifically designed to facilitate learning on a particular subject, and there are various kinds of tutorial software which fall under this category. They are also termed as academic software, and examples are listed below. We have Delta Drawing, G-Compress, Jumpstart Titles, KidPix, and Mindplay. We then move on to the next category, which is graphic software. Now, graphic software, as the name suggests, graphic software has been devised to work with graphics, as it helps the users to edit or make changes in visual, data, or images. It comprises of picture editors and illustration software, and some examples of these are Adobe Photoshop, Autodesk Maya, Blender, Carrara, CorelDRAW, GIMP, Modo, and PaintShop Pro. Then we have the web browsers. I think we all are quite conversant with web browsers. Now, a web browser is an application that we use to browse or surf the internet, and it helps us in locating, retrieving data across the web. And some of the common web browsers are Mozilla Firefox, we have Opera, Microsoft Edge, we have Chrome, Internet Explorer, Safari, UC browser, there is Brave, and all those other browsers you use on your phone. We have other types of software, and this will be example like what I'm using for this presentation, that is Microsoft PowerPoint. We have spreadsheets like Microsoft Excel. These deal with predominantly numerical data. Mail programs, this is what we use to send emails and to receive emails as well, and so on. Now, having understood software, there is another important concept we need to grasp, that is software licensing. And we are going to start by asking ourselves, what is software licensing? What is software licensing? Software licensing is a form of a contract between a person in a company that creates the type of software and the person who downloads or buys the software to use for his or her own purposes. Okay. Now, the license is that agreement, okay, that allows you to use a software that is made by an individual or some company. Okay. Now, what I would like you to understand is that it does not transfer ownership. You see, like, let's say if you buy your phone, the ownership of the phone is transferred from the company to you. When you're buying a software, you don't buy that software, you buy a software license. Okay. And this software license is now what allows you to use the software given or following the terms that you sign, okay, or agree with the software developer, being an individual or even being a company. Okay, so that is the software license. Now, we have different types of licenses. So we have freeware. So freeware software is payable without and is available without any cost, and any user can download it from the internet and use it without paying any fee. However, freeware does not provide any liberty to modify the software or charge a fee for its distribution. Okay, examples are, we have the Adobe Reader. Okay, and please know we have two types of, we have the professional version, that one you have to pay for it. Adobe Reader, you can download it for free, okay? We have Audacity, we have ImageBurn, we have Recover, Skype, and Yahoo Messenger. Then we have Shareware, okay? Shareware is a software that is freely distributed to users on a trial basis, and it usually comes with a time limit. And when that time limit expires, the user is asked to maybe pay for continued use of that particular software. There are various types of shareware, like we have adware, donationware, nagware, freemium, and demoware. Okay, and demoware can either be peopleware and fireware. And examples of shareware are we have now Adobe Acrobat, that is the premium version, GetRight, PHP Debugger, WinZip, and so on. The next one is open source. Now, these kinds of software are available to the users with the source code. The source code is like what we looked at. You're able to see the code that was used to create that particular application. And if you are an application developer, then you can actually go ahead and modify the software and add additional features to the software. For example, that is why we have so many variations or distributions. We call them distros of Linux, okay? Because now different people will look at the source code and make changes to suit their own particular hot needs. Now, open source software can either be free or chargeable, and some examples of open source software are we have the Apache Web Server, the GNU compiler collection, we have Moodle, we have Mozilla Firefox, and Thunderbird. We have the next one, which is closed source. We have closed source software. Now, they are also known as closed source software, and these types of applications are usually paid and have intellectual property rights or patents over the source code. The use of this is very restricted, and usually the source code is preserved and kept as a secret. Like, for example, Microsoft, Windows, Apple, iOS, and so on. So this is usually done, of course, to make money. The software developer, that is the company or the individual that makes this closed source software, wants to benefit from it financially. Okay, so that's why they decide to close the access to the source code. Okay, so with that, we've come to the end of the session, and in this session, that is the learning outcome 1, these were the areas that we covered. 1, definition and definition and functions of computer systems. We looked at various applications like PowerPoint, Excel, Spreadsheet, Outlook, the various types of computer systems. We looked at big data. I hope you remember the 5 V's. We then went on to look at the types of computer hardware. We looked at accessibility, categories of software. You remember the 2 broad categories, system software and application software. We've seen the use of application software. We looked at software licensing, and we also looked at system software. Now, with that, we've come to the end of the session. I would like you, in case of any queries, you have my email address, okay? So please, you can shoot me an email, and I'll be glad to oblige you. So with that, guys, have a nice time, and God bless. Bye.